Alright, so in this video, let's bust out some rotations. Okay, so the big idea with that, here, let me fix my pen. Okay, here we go. So the big four learning targets are, look over here, what in the world is a rotation? What is some vocab terms? We're going to throw some vocab terms at you. So like center rotation, what's the syntax? Oh, that's a cool word. So syntax basically means how do you write a rotation? And then what are some four common rotations that you're going to have to remember? You're going to memorize that stuff, okay? So let's check this stuff out. First of all, what is a rotation? What are the properties of rotations? So just real quick before we get into it, look, we got triangle ABC, and here's our center rotation, and that triangle is just rotating around that point. So you kind of intuitively know it just from life what a rotation is. But let's get into the nitty gritty here. Bust my pen back out. Number one, look over here. Rotations are rigid motions. So that means two things. One, that the angle measures and side lengths are kept the same. They're congruent. They're equal, okay? So for example, look over here. What in the world does that mean? So if you have angle B and that was 30 degrees, even after its rotation, angle B prime, what's going to be that angle? Yeah, if it's rigid motion, that's also going to be 30 degrees, okay? So that's concept number one, that rigid motion's angles are preserved. And also just the other part of that is that if you have a side length of BC, let's say that measure is 5, then after the rotation B prime, C prime, that also equals 5. Yeah. All right, let me erase that. Wait for me. Okay, so then point number 2, all points and their corresponding rotated points are equidistant to the center rotation. Wow, look at that word. That's a fancy word, equidistant. That means that it is the same distance. So these are like normal people words. That's like the fancy word, equidistant, same distance. So what that means is that this distance here from Q to A, if that was 5 inches, then after the rotation, this distance from Q to A, which is the center rotation, is also 5. Okay, so they're all equidistant. Same thing with the distance to B and B prime. Let's make this nice and messy. All right, let me get big eraser out. That's concept number 2. And look over here, concept number 3, all reflected points. Oh, ooh, I just found the error. Okay, I meant to say, scratch this out. All rotated points are rotated the same amount. Okay, so this is the angle of rotation, right? So if this is 30 degrees, so like say from B to B prime, let's say that was rotated 30 degrees, okay? So all that's saying is that the angle rotation from C to C will also be 30 degrees. All right, so here's the big question to you guys. Think about this. What would be the angle rotation from A to A? Yeah, so that's also 30 degrees, okay? So that's all that part is saying right there. Okay, so those are the 3 properties of rotations. Let's check out the next thing. Here's the syntax. So this is the syntax part. And so whenever you see a rotation, this is how it'll be written. So the rotation, and this is the angle rotation, and this is the center rotation, and this is the pre-image, okay? So you have a rotation of triangle ABC, which is this, about this many degrees, right? So let's say this is 30 degrees. And then about point Q, so this is the center of rotation. And that will produce this triangle here. So we could put an equal sign on this and put triangle A prime, B prime, C prime. Okay, so the point of this is just for you to get comfortable looking at this sentence and knowing exactly what to do, okay? Then you need to memorize these 4 special rotations on a coordinate grid. Okay, so here's how it works. Let me go real quick. So look at this first one over here. if you have a rotation of 90 degrees, what happens to x and y coordinates is that they flip around and then the y becomes the opposite sign. Okay, so let me show you how that works. Say you had the rotation of 90 degrees of 2 and 5, coordinate 2, 5. What happens, so this is the x, this is the y. What happens is that they flip around, right? So we got negative y, x. So the negative y, a negative of 5 would be negative 5. And you guys tell me what the x would be. So the x, we need to flip it over to this side. Okay, so 2, 5 becomes negative 5, 2. Now let me throw this puzzle at you. What if 5 was already negative? Uh-oh. So we got x and y, and we need to produce negative y, x. Okay, so if this is negative 5 already, oh no, what do? We need to make it the opposite sign, so it becomes positive y, and then that becomes 2. Okay, so all these other ones work pretty much the same way. These notes should be in your book or on the website. You can ask your teacher also. So you need to memorize these for it. The 90 degree, the 180, so x, y, and then flip the signs, negative x, negative y. And then a 270 degree turn becomes x, y, y, negative x. And then 360, nothing changes. It's the same point, okay? You go around a circle, you are in the same spot as you left off. Okay, so if you have any questions, try these problems out. And if you have any questions, ask your teacher, and I'll see you in the next section.